Hello everyone. Today I'm going to show you a little project that I'm going to work on. Basically I have a problem. I have these unprotected NCR 18650B Panasonic batteries. They're beautiful batteries. They're 3400 milliamp hour rated, and they're excellent. I mean, they're industry standard, best batteries you can buy. But my problem is they're unprotected. So if I put them into my flashlight, this is a Securitying. It's a 3 LED model. I believe it's 4,000 lumens. I'm not sure. It doesn't really matter. My problem is that if I put them in there, there's nothing to keep them from over discharging. So if you know anything about 18650Bs or lithium-ion batteries, is that you have to keep them between 2.5 volts minimum and 4.25 max. Okay, so if they go beyond those parameters, you'll ruin them, and they'll be no longer any good to you, or they won't hold as much of a charge, and you get into a dangerous situation at that point. So my solution for this is I bought a protection circuit module from eBay. It's a 3.6 volt. It says one single cell, and I believe it's for LiPo and lithium. Yes, it's for LiPo and lithium batteries, and it's just so you can see it. There's what it looks like. It is a very tiny little board with 4 contacts on them, 3 of which count. These 2 here, the positives, and I'll show you this on a bigger printout. But anyways, this is a protection circuit, and I bought 2 of these for $5 from China, so pretty good deal. And I'm going to put this circuit into this flashlight, therefore allowing me to use the NCR 18650s. Now I've tested this circuit with a full set of batteries on this flashlight already. Basically what I did is I took the circuit board out and soldered 2 pieces of wire to it, like that, positive and negative. Then I took my board, protection board here, hold on a second, and hooked it up to my battery bank, which is right here, like that, and basically just jumped all the tops of these batteries together with solder, wired them together, and then fed that circuit through this board to this flashlight. And at 2.5 volts, the circuit, the protection circuit right here, shuts it off. It doesn't even get hot while it's doing it either. It's just an on and off circuit, so it doesn't use very much power, and it works just great. So let me just hook it up here quickly. I have a positive here and negative. And as you can see here on this, I'll move this out of the way, on this circuit, the positive is just a pass-through. It doesn't matter. It's the negative where the circuit cutting actually happens. So let me show you just that working, and we'll go from there. Oh, gotta put my negative in here. There we go. And as you can see, it powers up just fine. And like I said, I've tested it down to 2.5 volts, and it does shut off. So the next thing I need to do after doing this, and I'll show you the whole circuit diagram here so you can see it. There it is on a printout. And basically your battery power from your positive and your negative connect here, and then your charge points are here and here. Positive to the positive on the head unit, and negative to the negative on the head unit. And what you need to do is bypass the battery flow, or put it in between the battery flow and the circuitry on the head unit, which I'll show you how to do as well. Now, this circuit actually here and here, this is just one strip. Basically, it doesn't matter. You could connect it here to here. It doesn't matter. The positive just flows through this circuit. It's the negative where the actual circuit is going to be cut. Alright, here's all the things I used to do this mod on this flashlight. I used some 22 gauge wire. I also used a little strip of some wire wrap wire that I have on the last solder, because it was easier, but I could have gotten away with doing it with that. It just would have been a bit more cumbersome, so since I have the wire, it's easier. Some 5mm shrink group tube for the actual protection circuit itself, and the shrink group tube should be exactly the same length as the circuit. as if it's any bigger, you'll have a hard time getting it into the head unit, which I did. So I cut it down to that size and it's fine. 6040s solder is what I use. You can use whatever you'd like, whatever kind of solder you have. I used a 20-watt fine tip soldering iron, spring hook to get the circuit off the back of the flashlight. Just a simple meter to test the voltages, and I also use a meter to test continuity. I'll show you how to do that here in a second. And a wire cutter and a knife. I used the knife to strip the wires and also to cut the traces on the circuit that were required for me to put the protection circuit back into it. Now, on the meter, if you want to do a continuity test, and what I was using continuity for was to make sure that when I cut a trace, that electricity wasn't actually still flowing between the two surfaces that I cut across. I wanted to make sure that I cut and open the circuit properly, and you can do that with a regular meter. Just put it on the ohm setting. I put it on 2000, and you can see there it says 1, which means it's open, or no resistance. And then you can just when you put the two leads together, you get a 0, which means you have a closed circuit. So if you're testing to see if there's electricity flowing across, or you want to use it as a continuity tester to see if anything's flowing across the circuit, then basically all you need to do is put it on one side and then put the other lead on the other side, and if it goes down to 0 or 1 like it does here, then you know you have a closed circuit, and if it's open, you've cut the trace correctly. Basically, I've tested the circuit out with 5 batteries. They're, I think, 1700 milliamps each, so they handle it just fine. And I'm going to use these batteries in there when I'm done, but basically all I need and what I want is battery discharge protection. Now, you could use the same circuit to charge this battery as well, but I think, I have a professional charger. It's a Nicor, and it works great. I don't need to charge them in this flashlight. It says here charge. The only thing I want is the discharge function of this board working in my flashlight. So next I'm going to show you how I'm going to hook that up. And as you can see here, I have the 2 leads here, but I'm just going to take that off. And you can see that the positive and the negative make contact here on the battery. So the edge is the negative, the center ring is the positive. Problem with that is you can't put any circuitry here because then the batteries would just smash it. So it's got to go on the other side. So let's look at the other side. Okay, to take the circuit board out of the back of the flashlight, I used a little spring hook like this here. And I just put the spring hook on the notch on the circuit. As you can see here, there's a notch. I'm not sure whether you can see it or not. Get into focus, sorry. There you go. There's a little notch on the circuit, and I just use the spring hook to pry up on that and lift it up. You can use whatever you'd like, And then after I was finished, I just put a little dab of super glue on the edge and put it back down on there. So it's up to you how you secure it back in. You could use silicone if you wanted to, whatever. I don't intend to ever have to take that cover again, so I just used some crazy glue in there, some super glue. So it's up to you. Again, I just used a spring hook, put it underneath and pulled it up. Alright, here's a better look at that circuit board. And I'm going to have to, basically what I need to do is isolate the negative connection from the outside ring to the inner circuit. So I'm going to have cut the trace here, 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 and here. And I'm going to just use a knife to cut basically a trench through the circuit, which will basically break the circuit from the negative outside ring to the inner circuitry. And then at that point I'm going to solder a wire from every single one of those right down to this solder pad here, and then from there to my circuit. So I'll show you that next. Alright, here's how I set up the actual protection circuit or board itself. I soldered one wire to the P and B positive terminals on it, because really they're just a straight through connection. On the PCB board, they're actually just one the same solder point. So I just used one wire to connect two of them, and that feeds the positive circuit on the protection circuit. So basically one wire will do just fine there, as you can see there. Then of course I put a another wire on the P negative, which is the discharge cable, and that's going to go to the negative part of the actual head unit or the flashlight circuit. And this negative here, the B negative, goes to the battery side of the circuit, which is right there. So let me just do a little, there we go. So it's there's a little bit better view of it. As you can see, one wire going to both of those, one single wire going to the P or the charge wire, and to the battery wire on the negative side. So let's go to the next picture. Then I just marked them so I know which one's which. Once I put the heat shrink tubing on there, you can just tell by the length of the wire, but just being efficient there. So go to the next one. Then I put the heat shrink tubing on, and one of the things I did is by mistake I made the heat shrink tubing too long. So what happens is that this is a really stiff board, and when you put the heat shrink tubing on it, it continues to be even more stiff, but it's too long and it won't fit in the head unit. So I actually chopped off, used a sharp knife, and cut the excess heat shrink tubing to the actual edge of the board. Same on this side, and it fit just fine. It was a tight fit, but it fit. So go to the next picture here. And this is a description of how the board works. Basically, the positive from the battery flows through this circuit board and then onto the lamp itself, or the lamp circuitry. And the negative is where the actual switching happens for the board. So as long as the voltage on the battery is over 2.5 volts, then the switch is closed and it completes the circuit and gives electricity to the lamp itself. But what we need to do is mount this board between where the negative from the battery feeds into the negative on the circuit board that drives the lamp, so that the switch can actually have a function. So basically what happens is the negative it gets disrupted by this board when it reaches below 2.5 volts. So I'll show you how I did that here on the next picture. So what I did, the outer circuit is the negative terminal coming from the battery itself. So this outer golden circle all the way around is the negative terminal. So what I did is I cut the circuit here, and I used my continuity checker, or my ohms checker, as will show you here in the video, to actually cut or open the circuit between the outer negative ring and the negative terminal on this rectifier here. And basically there's just a cut all the way across, and basically that opens the circuit. Then again here you can see that it goes to this circuit, the trace goes to the outer ring, so I cut it there. Same with this one here, cut it here and here. Here, this one you don't need to cut. Actually, I'm going to use it to connect the battery terminal side of the protection circuit onto this board. But regardless, make sure that you've actually cut the trace completely and that there's no electricity or continuity between this terminal here and the edge on every one of these, so that you can continue on to the next step. All right, the next step I did, I just basically looked at my points of where I'm going to solder these circuits together. So the reason for soldering these circuits back together at these points is to actually make them all a complete circuit on the negative side. And the reason for that being is that this is what is going to connect to the other negative side of the protection circuit. So I have here and here. You can see I scratched off the paint from the trace down to the metal, so that gives me a good place to solder down into. Here I'm going to use this point because it's already soldered on. And here there's I just put a little I did the same thing, just scraped away the paint and got down to the metal on that to create a solder point. But in the end I just soldered it right to the this capacitor here. or this C2 circuit, which I think is a resistor, but I'm not sure. Anyways, I just went from here to here, and I'll show you that next. And here's the wire actually connected. So here we go from this solder point to this solder point to this solder point. Now at this point here, this is a very short distance, and I was having a hard time with this 22 gauge wire. So I found a much thinner piece of wire, and it worked just fine. It's I use this wire for wire wrapping, so you'll have to find a thinner wire, or you can actually just, if you wanted to, use a very short piece of wire to bridge between here and here to actually complete that circuit. So once we have that completed, all those points are now connected again, but but still open circuit from the negative ring on the outside. So we'll go to the next picture here. So the next picture, in the next part of this process, I attached the positive lead down here, and you'll notice here that I didn't cut this trace point here because it didn't need to be cut. I thought I looked at it, and it actually doesn't go anywhere on the circuit. It's just there, I don't know, just for looks, I guess, because it doesn't actually, this part of the circuit doesn't actually connect to anything. It just goes underneath these two, looks like resistors, and just lies there. So I didn't have to cut that section. Anyway, the positive, if you see these little holes here, you'll see that, and there's a few more under here you can't see, but these little holes transfer the positive connection on the back plate to the front or the circuit side of this board. And there's an open solder pad here, so I used it to connect the positive or P plus or B plus part of that circuit. Then we'll go next. Here's where I put the the battery side negative on the circuit board. Right there on that little pad that was already provided for me but not used, and connected to the outer ring to the battery connection from the other side. So that completes the battery portion of that. And next we'll go and I'll show you the next one. And then I connected the P minus side over here on the actual first connection I made on this whole wire trace. So not sure if you understand why all this works, but basically what happens is that this part of the circuit is isolated from the outside ring, and the outside ring is then connected, if I go back, to the circuit through here. So basically that's what we got. That's a complete circuit. It's completed. It's hooked up, and as you can see here, I've cut the insulation off, the heat shrink tubing off the end of that to make it shorter. And then I just tuck all these wires underneath and cap it off like that, and then it's ready to be tested. I got the circuit back inside. The board's nicely placed in there, and I just put two little paper clip wires in there to hook up the negative and the positive to the battery. And as you can see, I got 3.59 volts. So I'm going to put turn the light on, and then put it on time lapse so you can see it turn off at well, hopefully you can see it turn off at 2.5 volts. The whole battery pack is being used over here. I got them all soldered together, and basically I'm simulating the flashlight being together by using these wires. So let's just hit start on this, and we have light. Let's check and see if we got all the modes. Medium, low, and I should have strobe. Yep. And I should have SOS next. I do. There we go. So let's test it out, see what happens. It should cut off at 2.5 volts. Okay, I wasn't able to catch it quite perfectly as I was using a 2-second time lapse, and the event seemed to happen in between the 2 seconds. But basically at 2.49 or 0.50, somewhere just right there, the light shut off, and the protection circuit actually shut it off, because right now it's still in that same state and I cannot turn it back on manually. So at this point, what's happened is that the actual circuit, protection circuit, is still protecting the batteries from discharging any further. And as you can see, they've actually recovered somewhat from that discharge state to 263, so 2.63 volts or 2.64 there. So next thing I'm going to do is I'm going to see if all I have to do is just disconnect the battery to reset the limiting circuit or the discharge circuit, the protection circuit. So there, I just disconnected it. You see it going down to 0 there. So I'll put it right back on again here and see if this should turn on again now. And it does. Look at that. So again, the protection circuit is actually reset once you disconnect the power to it. So exactly like it would be if you took the flashlight apart and took your batteries out. So the protection circuit's working perfectly in this flashlight. You know, I'm very happy with it. The other thing I learned too is that, you know, basically, you know, it's nice to have a protection circuit if you're not going to monitor the flashlight. But, you know, once you see the light down to this level, which is quite obvious to look at, you can look at it without squinting or anything. It's not quite as bright as it looks on the video. You would probably know that you're near the limit. But again, if you're not monitoring the flashlight and it's just left on, it's going to discharge down to 0 without the protection circuit in it. So I'm very happy with how this protection circuit worked. Check the video description for a link to the actual part that I bought from eBay. And thank you for watching. That's it for my video. Thank you very much for watching. If you like this video and it helped you out in some way, do me a favor, click on the like button right down here. And you know, if you wish to subscribe to my channel, just click on this link up here. And that should subscribe you to the Richard Lloyd channel, or Richard Lloyd USA channel. Okay, again, thank you very much for your time and watching.